Now I've just opened the 2-digit Display Manager LabVIEW project. I'd like to show you some of the details involved with the demonstration circuit for the FPGA subVI called Show Segments on Display. Now I begin with a 7-bit Boolean constant which initializes this feedback node, and then on each pass of the loop the bit pattern is rotated, and I can display that on the front panel. I send that off to the 2-digit display, and then I'm also using a push button to manipulate the display. I'm pacing this with a variable loop time, and then these two subVIs link together via a global variable, and the subVI in the bottom is responsible for actually establishing the connection to the 2-digit display. Let's take a look at this operating on the National Instruments Digital Electronics FPGA board. Note that we have segment A, B, C, D, E, F, and then G would be in the middle. And the push button is set up so that it operates the enables on the digits, and so we can selectively disable those. Alright, that's a quick overview. Let's take a look at some of the construction details here. The 7-bit array, or the 7-bit Boolean array constant, is easy to put together. It's important to realize that we need to go with fixed array size for this constant, however. So this establishes a size of 7 bits total. If you know that you're always going to be looking at the constant with all of its bits displayed, you can disable the index display. The feedback node serves as our 7-bit register, composed of 7 flip-flops ultimately when this is built on the FPGA. We see that the data type is established once we've connected something. Here's the array style indicator. And I'll also point out that you can stretch this out so it looks like a vertical display or a horizontal display. The bit rotator is found in the array palette. This initially starts out expecting a double data type, and it accommodates all data types. We can then create a constant, and this establishes the number of bit positions to rotate. It doesn't have to be just one. Here we have the connection to the push button switch, which is connected to one of the FPGA inputs. You'll notice that if you already have FPGA I/O resources established in the project, they show up. If you need to add something that you know is on the board, but it's not already in the project, that's easily accomplished. Here I'm adding a slide switch to the project. Now the loop pacing is established by the loop timer. That shows up right here. Now when you place this, you will see the pop-up window that prompts you to choose whether or not you want ticks, microseconds, or milliseconds. The size of the counter then is the number of those units that you actually need to count. 32 bits, of course, gives you millions of counts possible. Then I could create a control that makes this a variable from the front panel. Here's how I do that. I select the VI, and then I can place that on the diagram. You'll notice that it has the 2 array style inputs and then 2 discrete Boolean type inputs. Notice that the enable constant is false because the enables are active low. Now these 2 subVIs are linked by a global variable, and when I place manage 2-digit display, this subVI has no inputs nor outputs. Simply needs to be placed on the diagram someplace because it already contains its own loop. If we look on the inside of this, we see the global variable called toDisplay, and this subVI also contains the same global variable, and that's how the linkage is established between the two.